The classical approach for identifying an unknown analyte by mass spectrometry is to put the answer into your fragmentation software and then have that software assign fragment ions. This is known as circular reasoning. The big advantage of this approach is that only one answer is obtained. There is no ambiguity in the answer. Our mass spec approach generates simple models of molecules from the mass spectral data. This is done using accurate mass fragmentation data and an Excel add-in. Each fragment ion in a mass spectrum could be viewed as a group of one or more subfragments. These are groups of atoms that tend to stay together. We calculate these subfragment masses using the Excel add-in. The Excel add-in then checks these subfragment masses to find groups of masses that sum up to the mass of the whole compound. Usually there are over 1 million possible combinations of 3, 4, or 5 masses. The best combinations also sum up to the masses of the most intense fragment ions. In the next step, Excel converts each of these subfragment masses into possible formulas, which will then add up to the formula of the whole analyte. Here, this set of formulas explains 7 of the 12 ions. The 4 formulas of the subfragments shown here are in a linear alignment. The output is therefore a simple model of the unknown analyte. Often this is as far as this mass spectrum can take us. However, if this unknown analyte might be used in commerce or might be a transformation product of a commercial compound, we can go one step farther and search the massive PubChem compound database. Using a worksheet in the Excel add-in, some smaller formulas can be converted into SMART's representations of molecular substructures. We can then filter the massive PubChem compound database for compounds that have both the molecular formula and these 3 SMART substructures. In the PubChem compound database of 116 million compounds, there are 823 compounds with the formula C8H18N4O2. 38 of these also match the 3 SMARTs representations, although many of those 38 molecules have substructure connections that are inconsistent with the linear model that Excel created. 6 of the 38 compounds are drawn here. The 3 molecules at the top have both the linear alignment and the ordering of the substructures that are consistent with the modular structure at the top. The 3 molecules at the bottom have substructure connections that are not consistent with that modular structure. The spectrum analyzed was generated from PubChem CID 123831, top left. Our Excel add-in has several advantages. It works on almost all MSMS spectra that have some precursor ion intensity left. It's very easy to learn if you're already familiar with using Microsoft Excel, and it's reasonably priced. Thank you for watching this video.